Hello guys, welcome back to a new session. In this session, we'll be talking about the last section of chapter 10, which is about the polymer. We'll be talking about the types of polymer and the reactions that happen on the polymer and the properties of some of the polymers. Let us first define the polymer and what are the polymers, composition of the polymer, the types of polymer, as we said. Polymer are large molecules made up of many small units joined to each other through organic reactions. The small units are monomers or monomers. The monomers are small chains, small groups of atoms. When they combine, they form a long chain we call as the polymer. Okay, we call as a polymer. And how to convert the monomers into polymer? By having the reactions, and they do undergo through the reactions. Polymer can be made from identical or different monomers, can be made from the same monomers or different monomers combining together to form the polymers. Polymers are all around us. The food that we eat, the clothes that we wear are made of polymers. All of the foods, all the clothes that we wear made up of polymer. Some of the common natural polymer include starch, cellulose, and proteins. The starch, the sugar, cellulose, and the proteins, the cellulose sugars as well, they contain polymers. Some synthetic polymers may be familiar to you as plastics and synthetic fibers. The plastic and synthetic fiber are the other types of polymer that can be taken as an example for the polymer, guys. The polymer, in terms of thermal properties, it divided into two types: the thermosetting and thermoplastic polymers. The polymer can be classified in terms of behaviors when heated by an amount of energy. A thermoplastic polymer with a thermosetting polymer. What are the properties of thermoplastic? Melt when heated, can be reshaped many times. Melt when heated, can be reshaped many times. The nylon, the plastic, the rubbish bins, plastics, bottle, water bottle, the bottle for water, all the plastics that we use in our daily life can be melted and are classified as the thermoplastic polymers. But the thermosetting polymer are those types of polymer. They have rigid structure and they are durable of heat. They do not melt easily when heated. Keep its original shape. This usually used for the sockets of the electricity in order to not melt under a high pressure on when we heat the compounds. In terms of the types, other types of polymer, here we have got thermal properties of polymer can be explained by whether their structure are linear, branched, or cross-linked. So in terms of the structure, the polymers are divided into three types: the linear structure, a cross-linked structure, and then the branched polymer. Let us talk about all of these three types in detail. Guys, the linear polymer, the figure is represented, they are linear chains, continuous chain of hydrocarbons, monomers. They form a polymer, but they do not, there is no bonding between the layers, between the lines. The molecules of linear polymer are free to move. They are free to move on each other. They slide back and forth against each other easily when heated. So they are what? They are thermoplastic polymer. The first one, the linear polymer, are thermoplastic but can be melted easily. The second type are branched polymer. As you can see here, we have got branches from the chains. When we have got branches from the chains, it becomes a branched polymer that becomes somehow stronger than the linear polymer. The long molecule of the branched polymer contains side chain that prevent the molecule from sliding across each other. They will not be able to slide on each other as the linear polymer, which there is no branches in between the chains. More heat is required to melt a branched polymer than a linear polymer. We have to provide more heat in order to break down the branches and then melt this branched polymer compared to the linear polymer. However, branched polymer are still likely to be thermoplastic than being as thermosetting polymer, because we can melt them with the providing a higher amount of heat. The last structure of the polymer, types of polymer in terms of structure, is cross-linked polymer. The cross-linked polymer, instead of having branches, we have got bonds in between the chains. As you can see, the chains are cross-linked with each other. Adjacent molecules in the polymer have formed bonds with each other, as we have represented the shape. Individual molecules are not able to slide past each other when heated. When we heat the cross-linked polymer, they do not slide on each other. So the cross-linked polymer retain their shape. They will not be changed by heat, and when heated, it's the thermosetting polymer. So the cross-linked polymer is thermosetting polymer. The linear and branched polymer are thermoplastic polymers. We have got a note here, guys. The linear polymer are completely free to slide on each other, as we said, but the branched and cross-linked polymer are inhibited in movement due to having links in between the chains of the polymers. We have got two reactions of polymer. The first one is addition polymer. How to form the addition polymer? The addition polymer is the same as the addition reaction, which increases the saturation. Double bond becomes single, triple bond becomes double and single. Is a polymer formed by addition reaction between monomers that contain a double bond. So whenever a monomer contains a double bond, reaction happens, it becomes a saturated molecule we call as the addition polymer. For example, ethene can polymerize with each other to form polyethylene, or commonly called polyethylene. We call as the polyethylene. Here we have got ethene, which has a double bond under a catalyst, polymerize it to produce a polyethylene, a number of ethylene groups together. The double bond becomes single bond, so the saturation increases. The letter N represent this ethene can be as long as possible according to the multiple timers to form a polymer and belongs to the monomer the length of the monomer. In fact, this can be repeated hundreds or thousands of times, can be repeated as the monomers repeated to form the polymer. Guys, the polyethylene and the forms of polyethylene and related polymers. We'll be talking about the forms of some of the polymers, polyethylene and related polymers. The first one is HDPE. HDPE refers to what? High density polyethylene. High density polyethylene is the linear polymer. is the linear polymer. We talked about linear, branched, and cross-linked. This type is a linear polymer. It has a high density because it's a linear molecule compact together. We can pack the linear molecules together because of not having bonds, branches, and in between the chains, so it can be packed to increase the density of the molecule. Use it in plastic containers such as milk or juice bottle becomes HDPE because HDPE tends to remain stiff and rigid. They are stiff and rigid because of having a high density. It's used for the containers that to store the milk and juice and so many other products. So HDPE is high density polyethylene. The other one is branched chain form of polyethylene, which is known as LDPE. LDPE is the low density polyethylene. LDPE refers to the low density polyethylene. In terms of the density, is less dense than the HDPE high density polyethylene. LDPE tends to be less rigid than HDPE and is used in a plastic bags. It's used in plastic bags instead of using as the bottles for stored water or other compounds. Branched chain form when hydrogen atoms are removed from the molecule, when ethylene heated at almost in this condition of 200 Celsius and under 200 atmospheric pressure, and then ethylene molecule add at this location when under this condition. So how to form LDPE? By removing the hydrogen and attaching branches to the chain, we will form the LDPE. The branched chain molecule are not able to cluster as closely as the linear molecule. That's why they have lower density compared to the HDPE. The last one is a cross-linked polymer or polyethylene. We call as the CLPE. CLPE is cross-linked polyethylene. This is from the structure is a cross-linked polymer in terms of structure. It's more rigid than the HDPE and use it for objects that need to be very strong, and in terms of rigidity, in terms of strength, is much stronger than HDPE because the in between the polymers, the chains, there will be bonds. If guys, in this note, we have got a note about the polymers. When hydrogen atoms are removed from the polyethylene molecule, two adjacent molecule chain may bond with each other. This produces cross-linked. When we reduce or remove the hydrogen in the linear polymer, sometimes the hydrogen may be replaced by the chain or alkyl groups. The alkyl group, when replaced by the branches, it becomes the branched polymer. But sometimes when the two hydrogens removed and then the two chains cross-linked, it becomes a cross-linked polymer, the type of the type which is much stronger than the other types of polymer. Set this question: which of the following polyethylene is linear polymer? Of course, HDPE is linear polymer, and LDPE is the branched polymer, and CPE, which is cross-linked polyethylene, is the cross-linked polyethylene. The natural and synthetic rubber, we have an example for the polymer, which is a natural rubber, and as well the synthetic, the artificial rubber. The natural rubber is produced by the rubber tree Hevia brasiliensis. Brasiliensis, this is the figure which represents the natural rubber produced by this tree, which is called as the Hevia brasiliensis. It's formed as the result of an addition reaction. It's formed as a result of an addition reaction, which is the become more saturated, the unsaturated molecule. The monomer of natural rubber is 2-methyl-1,3-butadiene, commonly used as or called as the isoprene. Have a look on the this structure, guys. Here we have got one double bond from this side and one double bond from the other side, and the alkyl group methyl from that. So 1, 2, 3, 4. The naming 2-methyl 1,3-butadiene, the two double bonds, which is isoprene. Isoprene undergo through the addition polymerization to form polyisoprene. Polyisoprene, the addition of this polymerization, it becomes polyisoprene, which here we have got linkage of the isoprene with each other, undergo through the addition reaction. Guys, the natural rubber has few practical applications. In terms of practical application, it has few practical application. When warmed individual molecules of polyisoprene, which we talked from the isoprene, can be formed, slide easily back and forth past on each other. They passed on each other, so rubber gets soft and goosey, making it useless for many purposes. It's soft, that's why it cannot be used industrially. If we want to use the polyisoprene, we have to let the polyisoprene to undergo through a process we call as the vulcanization. So addition of sulfur to molten rubber polyisoprene produces a material that remains very hard and tough when cooled. As you can see here, we have got polyisoprene chains, and what added to the chains? The sulfur atom added. As we add the sulfur atom, the material becomes more stronger and harder. This process we call as the vulcanized rubber or vulcanization process. Name for this process is vulcanization, which is a cross-linked process between adjacent polyisoprene molecule that occurs when the molecules are heated with sulfur. When we heat the rubber, it becomes what? With the sulfur, there will be linkage in between them, so it becomes a cross-linked polymer, and then this process we call as the vulcanization. Vulcanization enables rubber to be used in wide variety of products such as hoses, rainwear, and tire productions in the automobile industrial applications. Polyisoprene is linear polymer. Often vulcanization, it becomes cross-linked polymer. Guys, polyisoprene, which we talked about, they are all linear polymer. But when they undergo through vulcanization, they become cross-linked polymer and become tough and stronger to be used for many industrial applications. Here we have got some synthetic polymers or some synthetic rubbers. Some synthetic rubbers have superior properties to a natural rubber. So the rubbers that synthesizes from the industrial processes, they have more applications over the natural rubber. For example, we have got neoprene. Neoprene is formed during polymerization of 2-chloro-1,3-butadiene. 2-chloro-1,3-butadiene is identical to isoprene. the monomer of natural rubber except for presence of chlorine atom in place of methyl group on the number of 2 carbon atoms. Have a look of the natural rubber isoprene, which is 2-methyl 1,3-butadiene, 1, 2, 3, 4. But here synthetic rubber is what we have got on the second, instead of methyl, we have got chloro 1,3-butadiene. So the difference between isoprene, which is the natural rubber, and then the synthetic rubber is what is here. In the natural rubber we have got a methyl group, then we have got the alkyl halide group, which is 2-chloro 1,3-butadiene instead. Another reaction which the polymers they undergo through is the condensation reaction. We talked about the addition, polymer and addition reaction. Let us talk about the condensation reaction. Condensation reaction, there will be 2 molecules condensed to form a longer molecule, and usually water in the product, as the condensation reaction. Is a polymer formed by condensation reaction. We talked about the condensation reaction in third section. Monomer of condensation polymer must contain 2 functional groups. They contain 2 functional groups combined to form one in the product. This allows each monomer to link with 2 other monomers by condensation reaction or condensation process. Here we have got nylon and the polyamides, a carboxylic acid with 2 carboxylic groups, adipic acid. Okay, here we have got adipic acid with 2 carboxylic groups. Here the carboxylic groups, and the amine with 2 amine groups. Here we have got amine with 2 amine groups, which is hexane diamine, react with each other through the elimination of water molecules. When adipic acid with 2 carboxyl group with amine with 2 amine groups, they react with each other. They form a longer structure we call as nylon 66, and then eliminate the water or produces water. This reaction is the condensation. As you can see here, they condense it together. They formed this functional group, which we call as the polyamide. When the carbon attached to oxygen and nitrogen or hydrogen, this we call as the polyamide, which is here we have represented and talked about the polyamides. Guys, nylon 66 is an example of polyamide polymer, and monomers of nylon 66 are adipic acid. The adipic acids are the monomers of nylon 66, contain 6 carbon, 1, 2, 3, 4, 5, 6 carbons, and hexane diamine contains 6 carbon as well, 1, 2, 3, 4, 5, 6 hexane diamine. Word of polyamide comes from the presence of amide in the polymer. Amide in the polymer, and the amide group is this structure with the carbon double bonded with the oxygen, nitrogen with the hydrogen, and then here we have got R. The chains as can be long as possible, depends on the chain. Polyamides can be fabricated into so many different forms, can be fabricated, produced, the applications. For example, they can be knitted and woven like natural fibers to have stockings and other types of clothing. For the production of the clothes, like the woven the clothes, knitting equipment is that can be used. This polyamide we use it when polyamides are treated with radiation. This is important. When polyamide are treated with the radiation, extensive cross-linkage occurs, there will be a cross-linking procedure, and the final product becomes very rigid and strong. The polyamides are not strong as the cross-linked structures, but when they undergo through radiation procedure by sending the radiations of light, they become extensive cross-linked and then become stronger. Kevlar is so strong, that's produced in this way, and it's used in the manufacture of bulletproof vests, the vests that the civil policies they use, made up of the Kevlar, which is polyamide polymers. Guys, here we have got the examples for the monomers and the polymer. The ethene or ethylene is monomer, but when it becomes polymer, it becomes polyethylene. 2-ethyl-1,3-butadiene is isoprene. It becomes polyisoprene for the polymer. 2-chloro-1,3-butadiene is monomer. It becomes neoprene in the polymer. And hexane diamine and adipic acid, hexane dioic acid, it becomes nylon 66 when it becomes polymer and they condense it with each other. Here we have got a note, copolymer polymer made up of two different monomers. This is copolymer extra notes. It's not given in the Kurdish book, but nylon 66 is an example of copolymer which is made up of two different monomers. Nylon 66 made up of the hexane diamine and adipic acid, or we can say hexane dioic acid, which are two monomers. They combine to form a copolymer. That's the end of the section, guys. Thank you for the attentions.